Elon Musk is betting Tesla's entire valuation on cameras that drive like human eyes. But right now, Alphabet's Waymo is already using expensive lasers to build a fully driverless digital subway in America's biggest cities. By 2030, autonomous ride-hailing is projected to generate over $1 trillion in revenue. This has triggered an industry-wide divide over how machines perceive reality. Waymo's approach relies on precision. Their vehicles navigate using expensive LiDAR arrays, radar, and hyper-detailed pre-scanned maps to understand their environment. Tesla moved in the opposite direction. They removed LiDAR entirely, opting for a camera-only system that attempts to mimic human sight using standard consumer hardware. The trade-off is clear. Waymo achieves extreme reliability within rigid pre-mapped geographic boundaries. Tesla accepts higher variance in unmapped edge cases today in exchange for broader geographic scalability tomorrow. This divergence creates two entirely different operational paths, one focused on perfecting a specific geofenced zone, and the other on mastering generalized driving in any location. In 2026, Waymo has an early operational lead. They are actively dispatching commercial driverless fleets across 10 major U.S. metropolitan areas. Rather than building a consumer network from scratch, they are plugging into existing platforms. In cities like Austin and Atlanta, Waymo's autonomous fleet is now integrated directly into the Uber app. Tesla's countermove targets the hardware itself. In April 2026, they officially began production on the Cybercab, a sub-$30,000 vehicle built without a steering wheel or pedals. Relying on vertical integration and their parallel unboxed manufacturing process at the Texas facility, Tesla's goal is to eventually produce one Robotaxi every 10 seconds. Waymo holds the lead in safe geo-fenced deployment, while Tesla is attempting to use its manufacturing scale to achieve mass-market reach. Scaling a Robotaxi service requires coordinating three distinct layers: the autonomy tech stack, the ride-hailing platform, and the physical fleet operations. Waymo's reliance on HD maps requires an infrastructure-heavy model. They must maintain local depots, charging stations, and ground logistics in every city they enter. This unit economics table shows that Waymo's estimated total cost per mile is $2.31. While competitive with human drivers, it is burdened by high initial R&D and vehicle builds that can exceed $100,000. This comparison table shows LiDAR and radar systems versus vision-based systems. Tesla's vision-led autonomy simplifies the hardware suite, lowering the bill of materials. By removing LiDAR, vision-based robotaxis target a production cost under $30,000, which moves the potential per-mile operating cost closer to 30 cents. Waymo is building an expensive, centralized corporate utility. Tesla's economic model targets a cost structure so low it could eventually make human driving financially unviable. While the physical sensors collect the raw data, the car's actual decision-making happens deep inside the neural network software. With the rollout of Tesla's full self-driving version 13, the company moved from simple behavioral cloning toward a system driven by end-to-end temporal transformers. This enables object permanence. By utilizing a 15-second memory buffer, the AI remembers objects and tracks their potential motion, even when they pass out of the camera's direct line of sight. This memory allows the vehicle to predict hidden trajectories. It aims to eliminate the micro-hesitations that occur when a system is forced to re-identify objects every time they reappear. However, this software-only approach faces real-world scrutiny. A recent $1 million lawsuit in Texas over an FSD crash serves as a reminder of the legal risks still facing vision-only systems. While U.S. companies navigate legal hurdles, Baidu's Apollo Go fleet in China has surpassed 11 million rides, demonstrating vision-led autonomy can scale internationally. Whichever company resolves the friction between high-level AI logic and unpredictable real-world edge cases will control the software standards for the industry. By the year 2030, we will likely see exactly how these two distinct technologies have fundamentally changed our geography. Bound by HD mapping and expensive hardware, Waymo is positioned to operate as a centralized urban fleet monopoly. They may structurally replace current ride-hailing services in dense metropolitan hubs, where highly controlled geofencing makes economic sense. Tesla is unburdened by maps. Their low-cost cybercabs are designed for mass scale, reaching suburban and rural markets that are currently difficult to automate. This shifts autonomy from a shared corporate service toward a privately owned personal tool. In this split reality, Waymo replaces your ride-hail, while Tesla becomes your personal driver. The human driver becomes the exception rather than the rule.